Welcome. So today we're here to talk to you about dead easy Kubernetes workflows with Visual Studio Code. And to get us started, we're going to tell you a little bit about ourselves. So hi, everyone. I'm Sarah. I'm a user experience researcher on Google Cloud Platform. And I do research to understand and improve developer experience with our tools. So it's my job to talk to all of you and listen to your needs and pain points and make sure we address those with our tools. And this is my dog, Smokey, who I love very much.
Hello, everyone. This is Sujit. I'm a software engineer on the Cloud Code team. I work on tools that improve developer experience with Kubernetes. And this is my cricket bat, which is pretty excited that after a long winter, summer is coming.
So how many people in the audience are developing Kubernetes applications or planning to in the future? Awesome. That's a lot of you. We're really excited that you're here. I've talked to a lot of you about your experience with Kubernetes, and one thing that I've heard is that it can be frustrating. And you've said things like, there's too much configuration, debugging is a pain, applications have so many moving parts, and you're just spending way too much time outside of your code. And so let's break this down a little bit. Why is Kubernetes difficult? Well, in my conversations with you, I've heard a few things like this. Getting started is hard, because it can be a big conceptual shift, and getting a Hello World application up and running just takes way too much time. And once you have Hello World ready to go, the complexity of Kubernetes really kicks in, because developers have to learn a lot of new things, like containers, YAML syntax, and Kubernetes client tools, like kubectl. And then when you're ready to deploy, there's a lot of moving parts. You have to build, tag, and push your images to your repository, and manage your clusters. And then if something goes wrong, which typically happens, troubleshooting can be a huge pain, because setting up debugging is difficult, and identifying the cause of your problems is hard. And so we want to help you with each of these. And Sujit's here to tell us a little bit about how.
Thank you, Sarah. So let me now introduce Cloud Code. Cloud Code is a set of integrated tools from Google that let you focus more on your code, worrying less about the tool chain, configuration, and management of your app. Over the past several months, we have been working super hard to help solve some of the pain points Sarah has described. And we are very excited to launch the Cloud Code extension for Visual Studio Code, which is currently in beta. So what do we have in this extension? This extension provides a simple getting started experience for users new to Kubernetes, helps with local application development, streamlines the deployment process, and help you troubleshoot your applications through debugging and logs. In today's talk, we are going to demo all of these and some more.
So that's a lot to cover, and we should get started. And I want to say, just as Sujit mentioned, we're going to be covering the end-to-end developer workflow with Kubernetes. So there's going to be a lot of code, but also a lot of really cool features that we're excited to show you. So let's jump over to Visual Studio Code. How many Visual Studio Code users do we have in the audience today? Awesome. We're really excited that you're all here and that we get to show you Cloud Code. So here I've got Visual Studio Code open, and I've got Cloud Code installed. So I'm going to get us started on the welcome page, which is going to have a lot of good resources when you're just starting with Cloud Code. What you'll see first off is that we've got support for 4 languages: Go, Node, Java, and Python. You're going to find information about the prerequisites to have installed when using Cloud Code. And for context, what I have on this machine here is Docker Desktop with Kubernetes enabled and Scaffold. And like I said, we really care about your feedback, and we want to make sure that we're creating tools to meet your needs. So we've got sections over here in the Resources tab for you to file an issue and request a feature. And we really hope you use those, because Sujit and I and the rest of our team are constantly checking what you'd like to see in Cloud Code so we can make improvements. And so now let's get started with our first Hello World app. As you can see here, I could get started right from the Resources tab, or I can use the command palette, Command-Shift-P. And I'm going to search for Cloud Code. And what you'll see right off the bat is a lot of contributions that we've made. We're not going to have time to go through all of these today, but there's so much for you to explore after our talk. I'm going to use the Cloud Code command for new application. And here you'll see the support for those languages that I mentioned, and a couple of templates that you can use to get started. I'm going to select the Python Hello World template, and it's going to ask me where I want to save that. And now it's going to populate a new Hello World template for me. Sujit, can you tell me a little bit about what this template has?
Sure. So all the applications that are created using the Cloud Code new application command are deploy ready and debug ready. So in this case, we have a simple Hello World application with a single microservice in it. All the source code of the microservice can be found in the source folder here, along with a Docker file that containerizes the microservice. We also have all the Kubernetes resources of this application in the Kubernetes manifest folder. And we also have launch.json file that contains the necessary debug configuration of this application. And finally, we have the scaffold.yaml file here. So Cloud Code leverages an open source tool called Scaffold that helps us with building and deploying Kubernetes applications. This Scaffold configuration file here contains one or more deployment profiles that defines how an application should be built and deployed. I would like to add one more thing here, that the templates we have seen just before are coming from external public repositories. This helps us scale the templates independent of the extension, and so over time, you can expect to find a lot more useful templates in this area.
That's really awesome, because providing more templates for developers is going to help them expand their Kubernetes applications quickly and easily. So let's go ahead and deploy this Kubernetes application. I'm going to go back to the command palette, and I'm going to use the command for deploy. And then I'm going to select the default profile, which came with my template. And then it's going to ask me where I want to deploy to. And like I said, I already have Docker for desktop on this machine with Kubernetes enabled, but we do also have support for Minikube. So here we go. We've kicked off our deployment, and we have it all ready to go. And there we go. I just deployed my first Hello World application, and I didn't have to write any code. So let's take a minute to summarize what we've shown you so far. We just showed you how easy it is to get started with our templates in Cloud Code, and how quickly you can deploy locally. But let's really get into it. Sujit and I have a question we'd really like to ask you all at the end of the talk. So we're going to build a voting application from scratch using Cloud Code. Sujit, take it away.
So let's build a voting application from scratch using the Cloud Code extension. The goal for the rest of the talk is to build and iterate this application locally. And when it's ready, we'll deploy it to a remote cluster so we all can access this application. The application itself is very simple. It has just two microservices, a front end and a back end called voting service. Even though we'll be using Node.js for both of these microservices, everything we are going to show in this demo is language agnostic. The front end has two HTML pages, an index page that lets us post a vote, and a results page where we can see all the voting results. And similarly, the voting service has two HTTP endpoints, a get endpoint that returns all the votes posted so far, and a post endpoint that will takes and saves a new vote. So now we'll go ahead and show how this final application is going to look like, so we all have a frame of reference of what we are trying to build. I'll go to cloudcodeexample.com, and now we are seeing the index page of the front end, and we can submit a vote. And as you can see, a post request has been made to the /vote URL, which is being served by the voting service. And similarly, when we navigate to the results page, you can see that a get request has been made to the /vote URL, which is being served by the voting service, and it returns all the votes that were posted so far. And these votes are being displayed in the results page here. So real simple. So now we'll go back to the IDE, and we'll close the Hello World application. And I will open a new directory called voting app, which is currently empty. I'll start by adding a source folder, which is where we'll keep the source code for all of our microservices. I'll get a terminal, and I will use git clone to fetch the source code for the front-end service, and we'll do the same for the voting service. The source code for these microservices is real simple. So the front-end service has an index.js file, which is configured to serve static HTML content from public directory. And the public directory has the HTML pages we saw before. And similarly, the voting service has the index.js file, and it has the implementation for the HTTP get endpoint and the implementation for the HTTP post endpoint. The votes posted will be stored locally on the machine using an NPM module. And both of these microservices have Docker files with them. And now, in order to deploy this application to a Kubernetes cluster, we need to have the corresponding Kubernetes resources. I'll switch back to the slides. And these are how our Kubernetes resources going to look like in our cluster. For each of the microservices, we'll have a deployment and a service resource that helps us with deploying and exposing this microservice within the cluster. We'll also have an ingress resource, which helps us in redirecting the external traffic coming to the cluster to these microservices. So all the traffic coming to the root URL will be redirected to the front-end service, and all the traffic coming to the /vote URL will be redirected to the voting service. So now let's add these 5 Kubernetes resources to our application. Is there anything more gratifying than writing YAML on a beautiful sunny day? Isn't it, Sarah? Isn't it what our customers are telling us?
No, not at all, Sujit. How many of you in the audience enjoy writing and editing YAML files? All right, you got a couple friends, but I'm going to say the majority do not. And so this is a great opportunity to show how easy it is to write YAML using cloud code, because developers are always saying that writing YAML can be error-prone, both syntactically and semantically. And we've got some really cool resources for you that Sujit's going to show us.
Let's do this. And no git clone this time. So we'll start by creating a new folder called Kubernetes manifest, which is where we'll keep all the Kubernetes resources of this application. And let's go ahead and create frontend.yaml file to add the deployment and the service resources for the frontend. The fastest way to add a Kubernetes resources is through our snippets. So I'll go ahead and press Control space here, and we can see a list of snippets available for us. I'll go ahead and use the Kubernetes deployment snippet, and now we have a basic deployment resource added. Let's change the names.
Woo.
Thank you. And now press a tab, and we'll change the image name to frontend image. And we'll do one more tab, and let's leave the container port as is. As you can see, adding a Kubernetes resource through our snippets is extremely easy. And typically, after adding a new resource, you may want to understand certain properties on them. For example, I may want to understand what this particular resource does here. For that, I can simply hover over those properties, and we can get a brief description of what the property is, along with a link to the official Kubernetes documentation. So next, we'll add a service resource. We'll again use the snippets. We'll use the Kubernetes service snippet, and let's change the name. And for a service to work with Ingress, the type of the service has to be either node port or load balancer. So we'll use node port here. And press tab. Let's use the port as 4001. And we'll leave the target port as is because it has to match with the container port here. So far, we have added both the deployment and the service resources that are needed for the front-end service. So typically, after adding new resources, you may want to fine-tune them by adding or removing certain properties. So in order to add new properties, you can simply go to the specific location and press Control space. And you will see a list of possible suggestions available at that particular location. So I can go ahead and use external traffic policy here and press Control space again. Now we can see the list of possible values for that particular property. We also have a brief description of that property on the right-hand side, which will come in handy when you want to decide which of these properties we would like to use. But for this demo, we won't need this property, so we'll not add it. So next, we'll try to quickly add both the deployment and the service resources for the voting service. We'll go to create a new file called voting.yaml. And we'll leave the container port as is, and then we'll add the service resource. Oops, looks like there's a typo. And as you can see, we also have a nice validation support available as well. Let's fix that. And now we have added 4 out of the 5 Kubernetes resources that we need for this application. Let's add the last one. We'll create the ingress.yaml file to add the ingress resource. Ingress resource helps us redirect the traffic coming to the cluster to the services in the application based on the host name, URL path, etc. So in our application, we have 2 services, the front-end service and a voting service. And let's redirect the traffic coming to the root URL to the front-end service. For that, I'll go to the service name and press Control space to get a list of available suggestions for the service names. Some of these suggestions are coming from the Kubernetes manifest in the application directory, as denoted by the local suffix. And some of the other suggestions, like Kubernetes and Python Hello World external, are coming from the current active cluster configured on my machine. So I'll go ahead and use the front-end service. And now we need to know the service port of the front-end. As you may have noticed, the front-end service here is clickable. So I can simply hover on the front-end service and use command-click, or I can right-click and use the go-to definition option. And now it takes us directly to the definition of the Kubernetes resource. I'll copy the port number, and we'll use it in the ingress. Next, let's try to redirect the traffic coming to the /vote URL to the voting service. For that, we'll add another entry here, use /vote. And now I'll use Control space once again and use the voting service. And now we need to know the port of the voting service. For that, we'll right-click on the voting service and use the peak definition option here. And now the definition of the voting service is displayed right here in this file. These features come in real handy, especially when you have large number of Kubernetes resources in our application. We also have the same tooltip support available in this mode. But we'll copy the port number and close this, and we'll use it here. And that's it. We have added all the Kubernetes resources that we need for this application. But before we move on, I will add a couple of annotations in order to use a non-default ingress controller and to stop SSL redirection.
Wow, Sujit, I just want to take a minute to say that you wrote a ton of YAML, and you made that look super easy. Those resources, like the snippets, autocompletes, go-to definitions, are going to be super helpful for developers who are new to Kubernetes, and those have been using it for a long time. So it's really great to see those features. And so to summarize, we've seen a lot of code. And what Sujit has done so far is gotten the source code for our microservices and Docker file, and then added all of the Kubernetes resources we need to deploy this application. So what's next?
Next, we'll try to deploy this application to the local cluster. So for that, I'll go to the command palette and use cloud code, deploy. And because there are no deployment profiles created in this application so far, it's prompting us to create one.
So wait a second, Sujit. Can you tell us a little bit about what deployment profiles do for us?
Sure. In real world, an application typically resides in multiple environments, such as dev, test, staging, prod, etc. And you may want to build and deploy your application differently based on the environment. For example, in dev environment, you may want to use Docker CLI to build your application and use kubectl to deploy the application to a local cluster, such as Minikube or Docker for Desktop. And in staging environment, you may want to use Google Cloud Build to build your application and use Customize to deploy the application to a remote GKE cluster. Deployment profiles help us do this. For each of the environment you would like your application to be supported in, you'll just have to create a deployment profile and let the cloud code take care of the rest. So now we'll go ahead and create our first deployment profile to work against the local environment. And for that, we'll click Yes here. And now it has analyzed the application and prompting us to provide a mapping between the image names in the Kubernetes manifest and the Docker files in this application. So why do we need to provide this mapping? Usually, in order to deploy an application, we'll have to build all the Docker files in the application, tag them, push them to a repository, and then update all our Kubernetes manifests with the image paths. The deploy process is asking for this mapping, so it can do all of these tasks on our behalf. So I'll go ahead and use the front-end Docker file for the front-end image, and the voting service Docker file for the voting image, and press save. And now we have our first deployment profile created. We can also see that the corresponding scaffold.aml file has been created in the application directory. So the default profile here is configured to use the Docker Engine APIs to build this application. And this behavior can be fine-tuned with the properties available here. And the default profile is configured to use kubectl to deploy this application. We can add more profiles as we need using the Add New option here, or we can use the Edit button here to edit the profile. So I'll go ahead and edit it. Instead of hard-coding all the file paths, I'll use a wildcard, so we don't have to worry when new files are added or existing files are removed from this folder. So now I'll proceed with the deployment, and we'll select the default profile we just created, and we'll use Docker for Desktop for the local environment. And now the deployment process has started, and we can see the status of the deployment in the status bar here. Currently, it's waiting for the rollout of the front end, and now it's waiting for the rollout of the voting service.
So Sujit, this seems to be taking a little bit of time, and I can see there's some error logs in the output window. What's going on here?
Looks like there's an issue here. So typically, after triggering the deployment, the cloud code deploy command also streams the logs from the corresponding pods directly to the output window. So which is what seems to be happening here. Just a second. Yeah, it was not visible in that mode. So we also have a few other options available to diagnose the deployment issues. And to access them, we can simply click on the status bar here. And here we can see the describe pods option if you want to know more details about the current pod status. And we have the show logs option here. But because we already have the error logs in the output window, I'll go ahead and stop waiting for the rollout. Let's see what's going on here. It looks like we are in index.js file line 13. We are using an await method in a non-async function. Let's go to the index.js file. And looks like we are using await incorrectly here in a non-async function. And because this bug is in the startup code of the container, the deployment has failed. So let's fix this and do a deployment again. Now the deployment is in progress again. And now the deployment has happened successfully. So as we can also see, all the publicly exposed endpoints in the application are displayed directly in the output window. I'll go ahead and click on the front-end service here. And now we can see the front end of our application, which is deployed in the Kubernetes cluster. So we'll submit a vote and see if we're able to successfully post a vote. Oops. Looks like the request to the voting service has failed with an internal server error. There seems to be a bug in the voting service code. And let's try to troubleshoot this issue by directly debugging the application in the Kubernetes cluster. In order to debug a microservice using the Cloud Code extension, we need to do two things. The first thing is to ensure that the Docker file that we are using is debug ready. So in the case of Node.js, that means using the inspect flag in the startup command. And we have similar instructions available for other languages in our documentation. And the second thing we need to do is to add the corresponding debug configuration. Currently, there are no configurations. We can add a configuration by using the add configuration option there. And we can select the Cloud Code debug here. But I will add the debug configuration in a slightly different way. I'll go to the .vs Code folder and add a new file called launch.json. And I'll go to the configurations section here and press Control space. Here we can see a list of Cloud Code debug snippets available for us. And because the voting service is written using Node.js, we'll go ahead and use the Node.js snippet. And here you'll see a number of options, but in most cases, you'll have to worry about just 3 of these. So the first is the name. Let's name it debug voting. And the second one is the local root. This is for the debugger to know the source code location of your microservice. The source code of the voting service is in the source folder here. So we'll go ahead and update that. And the third thing is the pod selector. This is to uniquely identify the microservice pod in the cluster. So we'll go to the voting.aml file and see the pod selector we are using. Looks like we are using app:voting. So let's copy this and use it in the launch.json file. And because we have updated the Docker file, let's do one more deployment. And now the application has been deployed successfully, and now we have everything we need to debug this microservice. So we'll go to the index.js file, and we'll set a breakpoint in the post method here. And we'll go to the debug window and press debug voting button. Next, let's try to submit the vote, and the breakpoint has been hit. Now we are live debugging the application deployed in a Kubernetes cluster. So we can see all the properties of the request object and the response objects. And we can step through the code line by line. And we also have some debug windows available on the left-hand side. So we have the call stack window. And we have the variables window here, where we can watch the block, local, and global variables. And we also have the watch window here. We can inspect the variable names. Looks like the vote we have just posted is coming out fine. Let's see what's going on in the votes object here. It looks like it's undefined right now. Let's step through. Looks like we are trying to access a property on the votes object here, which is currently undefined. And it's failing with an internal server error. So let's stop debugging, fix this issue. We'll instantiate with an empty object when it's undefined, and we'll deploy this. Let's see if it's worked this time. And now we're able to post the vote successfully. Awesome. So let's take a quick summary of what we have done in this section. So we started with an empty directory and added the source code for the microservices, along with the Docker files. And then we added the Kubernetes manifests that are needed for this application. And then we created our first deployment profile for our local environment. And then we diagnosed the deployment issues with the help of the logs that were streamed directly to the output window. And finally, we were able to debug an application deployed in the Kubernetes cluster and fix a bug. Awesome. So next, we'll try to take So far, we are only able to see this application on my machine here. Next, let's try to deploy this application to a remote cluster so you all can access it. Sarah, I know you use GKE. Would you like to show us how to create a GKE cluster within the IDE?
Yeah, I'd love to. It's great how easy it is to create a cluster right from within the IDE using Cloud Code. So I'm going to click our Cloud Code icon over here in the activity bar. And what we're going to see that's about to populate is all the clusters we have available in our GKE account. And if I want to add a new one, all I have to do is click this plus button, and it's going to open the cluster creation wizard for me, which is going to let me create a new cluster from within the IDE. And so what I can do is set a default project ID, choose a zone, whichever one I'm feeling like today, and customize my cluster. So give it a name. If I can type. And I can do things like enable Istio and Cloud Run right from in the cluster creation wizard. And then I can create this cluster right here. And I want to mention that while we're showing you this awesome workflow in GKE, we do know that a lot of you are using multiple clouds or other clouds. And so I want to point out that we have the support for AWS and Azure as well. And so I can go ahead and click Create Cluster and get this up and running. But we have limited time for this demo. So Sujit and I already made a cluster that's ready to go for our voting demo. I'm going to right-click here and set it as the active cluster. And then we're going to see it populate over here in our Cluster Explorer, which we'll talk about in a little bit. But we have a few more steps before this application is ready to deploy to GKE. Sujit, what do we have to do next?
Next, in order to deploy this application to the GKE cluster, we'll go to the command palette and use Cloud Code Deploy. We won't be using the default profile because it is configured to work against the local environment. We'll use the Add Edit Profile option here. And now we are back to the deployment profile wizard. I'll use the Add New option here to add a new profile. Let's call it GKE. And instead of inheriting the build settings from the default profile, we'll go ahead and change it to Google Cloud Build. And now, as you can see, the project ID has been auto-populated with my default Google Cloud project ID. Let's continue to inherit the deployment settings from the default profile, which is currently configured to use kubectl. If you need more customization options, you can directly work with the scaffold.aml file here. I'll go ahead and press Save and proceed with the deployment. And we'll use the GKE profile, and we'll use the cluster that Sarah has just added. And now it's prompting us for the image registry. Because we are deploying this application to a remote cluster, we also need to push the images to a registry which is accessible from that cluster. And it's currently auto-populated with my default gcr.io registry. Let's go ahead and use it. And now the deployment has started. While the deployment is in progress, I would like to bring to your attention a number of things that are happening behind the scenes. The Cloud Code Deploy command is building all the Docker files in the application using Google Cloud Build, tagging them and pushing them to the remote registry, in this case gcr.io. And then it will update all the Kubernetes manifests in the application with the new image paths. Then uses kubectl to apply the Kubernetes manifest to the remote cluster. After this, it will wait till all the deployment resources are rolled out successfully. It then waits till all the load balancers and the ingress resources in the application are assigned an IP address. And finally, it will pull all the publicly exposed endpoints in the application and display them right here in the output window. Now it's currently waiting for the ingress resource. Let's wait for it for a few more seconds. Awesome. So now let's use the link here. And now we are browsing the application deployed to the GKE cluster. Let's submit a vote. And awesome, it's working.
Great. I'm glad we got that all working. And I want to take a minute to go back to the IDE and show you all one of my favorite features of Cloud Code, which are Cluster Explorer. This is really great because it provides a lot of visibility into your Kubernetes clusters, which is something that I hear from developers, which is a really useful feature of Cloud Code. And so some things you can do here are see a lot of your Kubernetes resources right from the IDE, and you can perform simple actions against those and use them to find out more information about what's going on. So if we want to check out how our deployments are doing, we can open the Deployments tab, and we'll see both our deployments are running as expected, as indicated by this green icon here. If something wasn't going right, that would be yellow. We can look inside of our deployments to see the replicas, and if we want to scale, those will update. And if we want any more information, we can right-click to describe our deployment. And so we'll get all that information here as well. We can do some really cool things like stream logs right from our pods. So if we go into our pods and click on our voting application, we can stream logs right here. And we'll see that vote that Sujit just made coming in down here at the bottom, just getting blocked. And if I want to go back to our application and post another vote, we're going to see that vote coming in here too as well. And then we can go inside of our containers and get access to our terminal. And so if I click on the container for our voting application, we can get the terminal, and we can do things like ls inside to see what's inside of our container, right from the Cluster Explorer. And then we can check on the IP addresses for our services right here as well. So we can look at our voting service, and we'll see our IP address, and then we'll see the location of our port. And I want to mention that we have a lot of really awesome resources available here, too. We can see things like secrets, persistent volumes, and other environment variables right from the Cluster Explorer. And this is a really great way to increase the visibility of what's going on in your cluster. And as I mentioned, while we're showing you this in GKE, we do have the Cluster Explorer available for any Kubernetes cluster. So let's take a bit of a summary and see what we've done so far. So far, we've shown you how easy it is to create a cluster right within the IDE using our cluster creation wizard that works for AWS, Azure, and GKE. We've added a new deployment profile, and then we've deployed to GKE. We then showed you how you can see all of your Kubernetes resources right from the IDE with our Cluster Explorer. So let's test our app and make sure those voting results are coming in as we would expect them to. This is a little bit awkward. Sujit, there are no votes coming in. You write so many bugs in your code.
Yeah, please don't tell my manager. However, this is an excellent opportunity to showcase the remote debugging capabilities of the Cloud Code extension. So let's try to troubleshoot this issue by debugging the application directly against the GKE cluster. And because the Docker file that we have used to deploy the voting service has the necessary inspect flag already, we don't need to do anything else. We can simply ensure that the breakpoint has been set, and we can go to the debug window and click on the debug voting button. And now we'll go back and try to post a vote. Yes, the breakpoint has hit, and now we are live debugging the application deployed in the GKE cluster. So similarly, we can see all the properties on the request and the response objects, and we can step through line by line. Oops. Yeah, and let's see what's going on with the votes object here. It looks like we expect the votes to be stored in this format, but it looks like the keys in the votes are stored as indexes instead of the string. So let's see what's going on with the posted votes here. We'll step through. And the posted vote is coming out to be fine. And now we are iterating over the posted votes in this for loop, and we are updating the votes object. Let's go one step further and see the name. It looks like the name is coming up as a number here. Let's use, I think this is because we are using for in loop, which iterates over the array indexes, as opposed to the for off loop, which iterates over the array values. So let's fix it and press F5. Oops. I think there is a small issue here. Looks like it's continuously streaming the logs. I would like to close and open the application once again. Awesome. So far, we have seen how we can debug a single microservice in the Kubernetes cluster. Next, today I feel a bit brave and greedy, and would like to show you how we can debug multiple microservices in the application at the same time. Maybe I'm pushing our demo gods a bit too much here, but let's try this.
Fingers crossed for Sujit, everyone.
Yeah. So though I haven't explicitly mentioned, the Docker file that we are using to deploy the front end has the necessary inspect flag enabled. So we just have to create the corresponding debug configuration for the front end to be able to debug it. So we'll go to the launch.json and add another snippet. And let's rename this to be frontend, debug frontend. And we'll update the local root to the source code directory of the frontend service. And we'll update the pod selector. Now let's set the breakpoints. So previously we have seen that the results page of the front end will make a call to the HTTP get endpoint of the voting service. So we'll put a breakpoint in the results method of the front end, and we'll set a breakpoint in the HTTP get endpoint of the voting service. So next we'll go to the debug window, click on the debug front end. Now we'll try to navigate to the results page. And yes, the breakpoint has hit in the results method of the front end. We can step through and debug this. And next, when I press F5, the breakpoint has hit in the HTTP get endpoint of the voting service. Awesome, demo gods are with us. So I'll do one more deployment of the GKE cluster. So the code there will be bug-free, and Sarah will be happy.
So this is really awesome. I just want to point out how easy it was for Sujit to debug against the remote cluster. And this is really helpful because in my conversations with a lot of developers, debugging is one of the biggest pain points. And so we've just shown you how easy it is to debug a remote cluster. And it looks like we're going to show you a little bit more live debugging. It's how you know it's a live demo. As Sujit is diagnosing this problem, I just want to comment on a couple of the ways that we've shown you how you can troubleshoot using Cloud Code. We've shown you a lot of the logging features that are going to help you diagnose your issues. We've shown you that you can debug locally and against a remote cluster. And then Sujit bravely attempted to debug multiple microservices, which was successful. And so now we're going to debug this issue on the spot. Nobody panic.
I'll try to deploy to the GKE cluster once again.
All right, it's looking good.
So far, yeah.
We have to keep it very exciting for you guys, but there we go. Just pretend like nothing happened.
Yeah. Let's browse the application. Let's post a vote and see the results. Awesome, it's working.
Great. Well, I'm glad that we finally got that working. Thank you for your support. We appreciate it. And now that we have this great audience here, I think we could ask them a question that would be a little bit more fun.
Sure, what do you want to do?
So I know that we're working on a lot of awesome new features for Cloud Code, and I'd love to get the audience's take on what they'd like to see in the next release. So I know that we're thinking about things like Helm, Customize, CRD, and JIP. We should ask the audience what they'd like to see support for.
Sure, let's do this. In order to do this, let me introduce another command called Cloud Code Continuous Deploy. Previously, we have seen the Cloud Code Deploy command that does all the grunt work of deploying an application to a cluster. And the Cloud Code Continuous Deploy command takes it one step further. What this command does is it continuously watches the application directory for any changes. And when it detects any changes, it automatically deploys the application to the cluster. This command will come in particularly handy when you want to rapidly iterate on our code. So let's see it in action. So I'll go to the command palette and use Cloud Code Continuous Deploy. Let's use the default profile so we can iterate locally. And now the first deployment has started. And as soon as it's complete, we can see that the status has changed to watching for changes. So I'll go to the index.html file and update the text here. Which of these features do you want next? Awesome. So as soon as I press save, the deployment process has started without me having to explicitly trigger that. So we'll see the URL, and we can see that the text has been updated automatically for us. So I'll now go ahead and change the options to Helm, Customize, CRD, and we'll leave the zip as is, and we'll save. And now the deployment is again in progress. We'll refresh, and now the options have been updated. And we'll submit that, and it looks like we also have to update this in the results page. So we'll go back to the results.html page, to the options, and we'll paste this and press save. And once again, the deployment process has automatically started for us. Now we'll refresh this, and now the results page has been updated as well. So in order to stop the continuous deployment, we'll just have to click on the watching for changes and click on stop continuous deployment. So now I'll do one last deployment to the GKE cluster, so this application will be available for all of us with the new questionnaire. So also the Cloud Code continuous deploy command is smart enough to only deploy those microservices that are being changed by the user. So in this case, only the front-end service was getting redeployed again and again. One more thing I would like to bring your attention here is that as I deployed this application back and forth between the local and the GKE environments, I really didn't have to think about whether am I using the right build settings or the right deploy settings, or even the cluster that I'm actually deploying my application to. We just had to create a deployment profile for each of these environments, and the Cloud Code is taking care of the rest. So we'll browse this application one last time, see if everything is working as we would want. Awesome. Now, let's go back to the slides and take a quick summary of what we have done in this section. So in this section, we're able to remote debug the application deployed in the GKE cluster and fix a bug. And then, with the help of the demo guards, we're able to debug multiple microservices at the same time. And finally, we're able to use the Cloud Code continuous deploy command to rapidly iterate on our code and update the questionnaire.
Great. So now that we've got our voting application up and running, we'd love to hear your votes. So you can go to this link right here, cloudcode/demo, or you can scan the QR code on the screen. And for those of you, you might notice that this domain doesn't look exactly like the IP address that Sujit was testing against. I want to tell you that we did connect our GKE cluster to this domain before the demo. So I promise you it's the same code. And we'd really like to see your votes because we're going to be checking these later. And so if you don't vote, we're just going to get what Sujit wants in Cloud Code. And so while you're all voting, I just want to take a little bit of time to summarize some great Cloud Code features that we've talked about today. So as you saw, we have support for local development with Minikube and Docker Desktop. As I mentioned, we have support for any Kubernetes cluster with our Cluster Explorer, and then cluster creation with AWS, Azure, and GKE. We also support multiple environments, containers, and languages. So there's a lot of flexibility with this tooling, and this is just the beginning for Cloud Code. And so we're really looking forward to continuing to expand our support to meet your needs. And now the moment you've all been waiting for. How can you get your hands on Cloud Code today? So you can install and find all the documentation you need for Cloud Code at cloud.google.com/code, or you can scan this QR code here on the screen. And Cloud Code is also available in the Visual Studio Code Marketplace. For those of you who use IntelliJ, I also want to take this time to mention that we do have Cloud Code for IntelliJ, which you can find in the JetBrains plugin repository. And you can find all the documentation at the same link on the screen. And so we're really excited for you to start using Cloud Code. And as I mentioned in the beginning, we really do care about your feedback, and we take it into consideration when we're making these products. So we're logging all of our issues on GitHub. So you can file issues there, and our team will be very fast to respond to you and take those issues into consideration when we're updating Cloud Code. So we do encourage you to do that. And while you're out at the conference, I'd like to encourage you to come talk to other user experience researchers at our CPUX booth. There's a lot of us there, and we're always looking to talk to you about your needs and pain points so we can improve our products. So please come by and talk to me and other researchers at the UX booth. And if you'd like other ways to participate in our research and inform our products, sign up at userresearch.google.com. So let's check those votes. Wow. All right. Helm is winning. That's awesome. That's really cool to see interest for a lot of these different features. And Sujit and I will bring that back to our team to make sure that your voices are heard and we can make those changes for Cloud Code to meet your needs.
I think we're just scratching the surface of helping our developers and operators to be more productive. And we really hope you all will join us in this journey. Thank you.
Yes.